Today I will explain you the change of scale property for Fourier transform. Yes, change of change of scale property. Yes, scale property. Okay, this is this property. Okay, according to this property, the first property we have defined here for the Fourier transform. If f of fx is equal to f of p, then f of ax, this is equal to 1 by a f of p by a. Similarly, you have proven the Laplace transform. Okay, therefore for here this property, and similarly if we have write the scale property for the sine and cosine. Okay, similarly the next one we have defined the this scale property of sine transform is if f of x is equal to f of s p, then f of ax, this is equal to 1 by a f of s p by a for the Fourier transform. Yes. Now next, similarly the next property is for the cosine. Yes, if f of c, f of x for this function, this is equal to f of cp. Okay, then fc f of ax, this is equal to 1 by a fc p by a. This is the change of scalar property for the Fourier transform, Fourier scale property for the Fourier sine transform and Fourier cosine transform. Yes, okay, now we proved all these properties. Okay, now first one we have proved the first property. Yes, okay, clear? Proof of these properties. Yes, first one. Yes, here as for the Fourier transform, we know that f of p is equal to 0 to infinity, minus infinity to infinity e to the power ipx f of x dx, this one, and also here, and this is equal to f of x. Here this is also, you can say that f of x. Now for f of ax, if you write this one, then again operating the same property. Here the function is f of ax, so this can be written as minus infinity to infinity e to the power ipx f of ax dx. Here substituting ax is equal to, let ax is equal to t, then a dx is equal to dt. Okay, substituting here you get this is equal to minus infinity to infinity, yes, e to the power I, and this x become here, yes, x is equal to t by a, yes. So this can be written as 1 by a is here, so 1 by a, yes, 1 by a minus infinity to infinity, e to the power I p t by a in place of x and f of t dt. Clear? Now, and this can be as this is equal to f of a, so this is equal to, in place of t here is tx, so this can be written as this is 1 by a, yes, 1 by a, and f of if you change the definite integral property, a to b f of x dx is equal to a to b f of t dt, so this can be written as minus infinity to infinity e to the power I p, yes, p by a we take, yes, p by a t and f of x dx. Here the e I p t I p x in place of x. In next term I have defined you 1 by a minus infinity to infinity e to the power I p by a x, yes, f of x dx. So this is according to Fourier transform, this is equal to 1 by a f of p by a. Yes, clear? Similarly, we can prove for the sine and cosine transform. Yes, similarly for the next next property, that is for the sine. Yes, we take here the 0 to, as we know that 0 to infinity, yes, e to the power f of x sine px for the sine transform, so in sine px dx is equal to f of sp. Yes, we know that. Yes, sine px dx is equal to f of c. So operating, so f of s of f of ax, yes, this one is again is equal to 0 to infinity, yes, f of here ax, yes, and sine px dx. Is clear? Now, as we earlier here you substituting x's, similarly we can here we also substituting ax is let ax is equal to t, then a dx is equal to dt, and also x is equal to t by a. Yes, if you substituting this then you get integral which is become the same. Yes, 1 by a, because if you take the 0 then this is again 0, if you take infinity then this is again infinity. 1 by a 0 to infinity, yes, 1 by a 0 to infinity ft, and here is sine p, and in place of x you write t by a and dt. Okay, now this can again be by using the definite integral property. Yes, 1 by a 0 to infinity, yes, f of x sine, yes, P by A x dx. Yes, and this is again is equal to 1 by A and f of s p by A. Clear? Yes, this is this one. Similarly, we have proved it for the cosine property. Yes, similarly, we have proved it for the cos series. Yes, yes, that is for the cos series. Yes, yes, for cos series, we know that third point. For cos series, yes, for cos series, we know that, yes, for this, for property third, yes, 0 to infinity f of x cos px dx. Yes, for the cos property, this is equal to f of c p. Yes, again from the f of c, f of ax. Yes, this property, this can be again operating 0 to infinity f of ax, and here is cos px dx. Yes, now again substituting, here is ax is equal to t, then a dx is equal to dt, and also x is equal to t by a. Okay, putting this, we get, yes, this is equal to 0 to, yes, 0 to infinity, yes, f of t, yes, and this is sine. So in place of, here we write as sine cos of, for cosine series, yes, cos of, yes, cos of p, in place of x you write down t by a and dt, and also 1 by a is here, so we write here 1 by a is here. Okay, now similarly this can be written as 1 by a 0 to infinity, yes, and here is also f of x cos p by a x dx. Yes, so this can again be written as 1 by a f of c, yes, f of c p by a. That's clear. This is the property same for the cos property. Yes, in next video I have defined you some other properties. Okay, friends, thank you.